We're going to start this system up now. We've got the usual thing here we call the public push button over here. We'll push that to start everything. It says push and release when the status light is red. Here's our main status light here. We've got two duplicates over here on the sound decoder. So our control panel, we want to select our 4 tracks, run all 4. So we'll pull these buttons down to the on position, and then we want to turn the announcements on. So we have 3 announcement buttons. We'll put those in the on position. We can run this with and without announcements. We also have NCE lights, which will indicate which track is being operated. So let's go ahead and push the start button. You can see that changes to red.
Platform 6 is the 11:54 a.m. silver meteor service to Fredericksburg. We'll be calling at DeBerry, Sanford, DeLand, Deltona.
That was the announcement for track 1, which is that engaged loop up on the very top, the red one operating. So that'll go around for I think about 40 seconds or so. And you can see the light for track 1 is lit right here. So those lights tell us which track we're trying to run. In case a train doesn't start, we can look at that light and see which train is the one that's supposed to be running but not running.
Train number 17, Santa Fe Super Chief, now ready and loading on track number 4. Passengers for Kansas City, Dodge City, Laramie, Albuquerque, Dallas, Winslow, Williams, San Bernardino, and Los Angeles. All aboard.
You can see the track 2 lighted is now lit, and track 2 is that Santa Fe engine that just started up. Now that the top loop in the one we're running now, track 2, we have no way to know exactly where they're going to stop because we're just using time delay. Since that's a sound decoder engine, a Kato with an ESU decoder, we can blow the horn partway around.
The Continental Limited. All aboard. This train for San Francisco, Denver, Chicago, Washington, Philadelphia, New York, and all points east. Forward.
So now our light, it tells us we're running track 3, which is at Union Pacific E9, and that's also a Kato Loco with a ESU sound decoder. Now we put a Z-stuff detector over there by the barn, which we can use to position that train when it stops using a time delay. I think it'll stop on the next loop. When we go past that detector and trip it, we start running a time delay of 9 seconds. And when those 9 seconds ends, we stop the train. And that'll park at about the same spot every time.
Number 28, Pennsylvania Broadway Limited. For Crestline, Pittsburgh, Altoona, Harrisburg, Philadelphia, Newark, and New York. Sleeping cars only. Leaving on track number 2. Aboard.
Now our DCC-operated relay closed. We're using an Azatrax relay, and you can see the light came on in the stop block, which indicates we're putting power into the stop block via the relay. And we're using a blinking light it for that. I should say program the light it to be blinking for that, just to show it's analog, but that could be a solid light. Now you can see the light went out in the stop block, so the next time that train comes into the stop block, it'll stop. And you can see our status lights, everything ended. Our status lights changed back to red, which indicates the system is ready for the push button to be pushed again. We can also close the repeat switch to keep this thing running continuously if we want. When we ran that last demo, the train on track 2, the Santa Fe engine parked behind the mountain. As I mentioned, we don't know exactly where they're going to stop, so I'm going to use the power cab here to manually bring that out behind the from behind the mountain. We'll get it back into sight. There it comes. Now for our next demo, we're going to turn that track off just to show we can use any combination of the 4 tracks. But the point I want to make here, beside moving that train, you've still got full manual control of your layout. This programmable controller down here, which is operating things, acts like essentially like a robotic cab, like you had a robot controlling one of these. But when it's either idling or completely depowered, it doesn't affect the layout at all. Now we can run any combination of these 4 trains. We're going to run a second demo without the announcement, so I'm going to turn off the announcement buttons here. And I'm going to also turn off track 2, which is that red Santa Fe logo. So now we're just running tracks 1, tracks 3, and 4. Again, we can run any combination of all 4 or trains sequentially, or just any combination of those 4. So I think we're ready to go. We got our announcements turned off. I'm going to close the repeat switch. Means it'll run through one cycle, and then with the repeat switch closed, I just pushed it down to on. With the repeat switch closed, it'll keep running cycles continuously. So here we go with the pushing the start button. Status light green. You can see our train up on track 1 has started up, and we're running track 1. That's a Bachmann logo with a decoder, but it has no sound. And again, without any kind of a detector, we can't really control where the locos stop. We just run them using time delay. That is to say, we just let it run for 40 seconds or so and stop it. And I can see the light shifted from track 1 over to track 3 because we're skipping track 2, not running that train. So it's going to run track 3. And again, because we had the detector, we can use the position relative to the detector to park the train pretty close to where we want to park it. Now there we're coming in and stopping with track 3. Now you see the light shifted to track 4 and our stop block light turned on. So we're now running that analog train that has no decoder. We've got a NCE switchcat, which is operated by the DCC system, controlling an AutoControls relay to turn that stop block on. And again, the stop block goes from that red mark on the track over to that red mark. Now the stop block's off, so that'll stop. Now since the repeat switch is on, it's going back and running through a second cycle. You can see the train up on the top started, and it's running track 1 again. So now let's turn the repeat switch off, which means when it goes through its cycle, this time it gets to the bottom of the sequence, it'll check, and since the repeat switch is open, it'll stop. Now we're back on track 3, running track 3 again. So if you're running some kind of a public display or just a home layout where you want to let the visitors start the trains, you can set it up so they push the button and the trains run either just through one sequence like we demonstrated earlier with the announcements on, or you can have it run continuously. And like I mentioned, those two diesels on the lower end gauge loops, those are Kato diesels with ESU low sound DCC decoders and sound. Now there's track 4 starting up. And again, we're using that lighted in a blinking mode, but that could be solid. There's actually about 12 or 15 different lighting effects you can program into the lighting, since these are meant to be used in like passenger cars or buildings or wherever. Now our stop block went out, which indicates we're done running that, and we just have to wait till the train comes back around to the stop block and it'll stop. And you can see the status lights going back to red, indicating that we're telling the public or telling our audience they can push the button again to start the trains again. We mentioned earlier the idea of this train choreography is you can choreograph a little performance with your individual trains and departure announcements to kind of present in this case, a 5-minute show for your trains by running them individually instead of all at once. However, you still have the option to run them all at once, which we'll show now. We've opened all these buttons here. We're going to close this one button that says run all 4. We're going to close the button that says repeat. So that'll run all 4 of them at once. Let's push the start button. And notice all 4 track lights come on at once to indicate we're starting up all 4 tracks at once. So that way you can use the mini panel, that is to say this programmable controller, to still start all 4 trains at once at whatever speed you want to have them running. And they'll keep running since the repeat button is closed. They'll keep running continuously. Now if we open the repeat button, they'll stop pretty soon. They check every 30 seconds. Okay, it just came around and stopped. Let's do that demo again with the repeat button open. Now it's starting all 4 of them up again, and I believe there's 30 seconds programmed in there that they'll run for about 30 seconds and then stop again. And you can of course change that time delay to anything you want. You can have them run for 1 minute or 2 minutes or whatever amount of time. Okay, we're still running. If we watch these lights, that should go out after a certain amount of time. There they go. They just went out to indicate it timed out. So the point being, you can have your public control push button, start them for 30 seconds, a minute, 2 minutes, 5 minutes, and stop them. Or you can use the repeat switch in the close position to have them run continuously until you open it again. Let's take a closer look at this relay in the on the analog loop. And like I mentioned, we're running one analog train. We could actually run all 4 of these could be analog trains. We could probably even run 5, 6, or 7 analog trains just using DCC controlled relays. The path of this is we're pulling power off the center rail. There's a track hookup over here, and we're bringing this wire over to this terminal block here, going into this Azatrax relay, which is a 8 amp, I believe, double pole, double throw relay, going back out the other side of the terminal block and down to the center rail inside the stop block, which is underneath that passenger car. So that's how we can turn on and off the power to the center rail in the stop block. And we can do that with the programmable controller, as you've seen in the demos, and we can also do it manually using our power cab. Let's see if we can demonstrate that. We're gonna say accessory 5, and you select accessory, and we're going to do accessory 5, which is what that's set to. And if I say enter, if I say norm, which is a 1, you can see it turned on that stop block. The light over there, you can see that light came on to indicate there's power inside the stop block. And if we turn it off manually, again using the cab, we can say select accessory 5. We'll select a 2 for reverse off, and you can see it turned it off. So that's how we get power in and out of that stop block. Now, and that relay is being powered by an NCE switch cat. The cat, K-A-T, being, I believe, for Kato turnouts, because that's probably what it's most commonly used for, is controlling a Kato turnout or an LGB turnout, anything that has 2 wires to it that requires a DC pulse. But it'll also control this relay. And the late Fred Cupp, who hooked some of this stuff up for me, put push buttons on that, so I got a pair of push buttons in my hand, so we can turn that on and off using the push buttons as well. And notice that that passenger car has a roller, one roller on the front of it, which is inside the stop block, so you can see that gets power put to the lights because the roller inside the stop block is picking up power. And you also notice that's an old Lionel car. These MTH cars have 2 rollers on them, so if we roll one of those into the block, you notice it puts power into the block because the roller back here on the main line is bringing the power to the roller inside the block and energizing the stop block. And in fact, I had problems trying to run this car behind the engine. It kept putting power into the block that would roll through it. I would have had to make a longer stop block to run cars like this behind the engine. As we mentioned before, the length of this block is from this red mark here over to the other one, which is out of sight, but it's right where the cab of that Loco is. From this point of view, we can see where we're putting power into the O-gauge track. Over here we've got an American Flyer AC transformer, and we've got that hooked up to the track. And I need to make clear the track power is AC coming from this transformer, because that's what that MTH engine typically runs on, is AC. If this was a loop of LGB track or some kind of an HO train analog, this might be a DC power pack, but we're using the power pack to put the power to the track. The NCE power cab is just powering the relay that turns this track power on and off over there in the stop block. Now, something else we should talk about. We should talk about an option to putting that stop block in, which is what we're using right now, would be to put the relay in the wire going to the center rail, have the relay here. The advantage of that is we wouldn't have to make a stop block over there in our track. The disadvantage is it would be harder to control where the train stops. With the stop block, we know the train's always going to stop in that stop block. Without the stop block, our wiring's easier, but we don't really have control of where the train is going to stop. Now, one other option we'd have, if we put the relay here in the wire and didn't have the stop block, we could use some sort of a detector alongside the track to sense the presence of the train. And then the same as we did with that end gauge loop, we could use this detector to inform our train controller, our mini panel, when the train arrived, and had the mini panel cut off the power right at that point. So that would be another option. Now here's 3 other options for relays for controlling the analog trains we can show. If you go back to video 833, which is what this drawing is for, that's the year 2021 Chuggington video. We ran 2 Chuggington Locos on a loop that had 2 passing sidings. So we had 2 stop blocks, one stop block controlled by that ASATRAX relay we just looked at, the orange colored thing. The other stop block was controlled by an LGB relay, which is really an LGB switch motor with a set of their 1203 double pole, double throw points plugged in the end. And that's what we're going to show here next. And incidentally, the Chuggington, we did the same thing. We had an AC Lionel transformer putting power into the track, but we used these 2 DCC control relays to turn off the 2 stop blocks and also to control the MTH turnout to run these 2 Chuggington Locos. Plus in the video, we ran a 3rd loco point-to-point using DCC. Now that's the drawing for that 833 video. Here's the relay. This board is actually left over from the 833 video. I took the ASATRAX relay off, which was here, and it's on our current layout, but the LGB relay is still here. And here's an LGB switch machine, switch I should say, turnout, and you can see the similarity. This is the switch motor here, which is the same thing as this, and then it's got a set of relay points plugged in the end. What you do is you pop the end cap off here, and you get these points and plug them in. Now these are expensive is one problem, but sometimes you can find them used at the train shows, especially the switch motor, because that's on lots of switches. And the disadvantage, besides being expensive, it'll probably wear out faster because it's actually electromechanical. If you take one of these apart, and I've done it, you pull 4 screws off, pull the top off, there's a little motor. It almost looks like an HO motor that would be in an HO locomotive, but there's a little motor with a gear, and this rack has a gear on it, a pinion gear, I guess you just say, and that's what operates this thing. So if you get one that's even dirty, you can take it apart probably and clean it. So the disadvantage, but it's not going to last as long probably as an ASATRAX relay. But the big advantage of it, which is what I'm going to talk about next, it has these arms that move. These would normally power the rail. If you look at the switch here, you can see that arm. That arm is what's moving the rails. But when you use it as a relay, you've still got that arm, but it gives you a visual indication of how it's set. Plus, you can also very easily set it manually. So that's the first alternative. We can demonstrate operating our LGB relay from our cab also. And by the way, this old control board, we've just got it temporarily connected over there to the power control panel on the layout via a pair of alligator clips to get power over onto this control board. But coming back here, the LGB relay is still connected to the second switch cat we have, which is set to accessory 10, so we can use our cab to demonstrate running that. If we say select accessory, and we're going to go accessory 10, enter, and we're going to set it 1 for normal. You can see that arm move to the front. That's the way we were using to turn the block on. Then that same thing to turn it off again. Select accessory. It's defaulted to 10. Push a 2 to turn it off. You can see it turns off. So that's what it's like operating from the cab. And basically the mini panel, our controller, sends the same type of commands to operate this thing automatically. Now our second alternative, we've used this in previous videos for our status light. Going back to this, they say this has a 3 amp rating, but I think that's very conservative because back in the 1990s, the late Ed Zellner in Denver used to run double-headed white pass diesels in LGB. That's 4 big motors, 2 for each diesel, pulling long trains of cars. And I'm sure he was pulling way over 3 amps. So these things seem to be pretty hefty. Now back to option 2 that we can show you. This is a Circuitron Smail, which is essentially a Circuitron tortoise, but it comes with a NCE decoder inside, so you can operate it off of DCC. And in past videos, we've used it to operate the status light, which is what you're seeing here. This is one I got off of Amazon, and we still have a set of points left over that we're not using, so we could use this to start and stop a track as long as the current was not above 2 amps, and we could also operate a light, a red-green light for that track. This is set to accessory 999. So if we say select accessory 999 and we say 1 for normal, you can see it goes to green, and you may have noticed the little mechanical arm move from the left to the right. I've got red tape on it so you can see it easier. And if we'll go back the other way now. If we say select accessory 999 and we want to go to off, which is 2, which will bring it back to the red. There it goes to red. So that's how we did our status light in the previous videos. But what we're doing now using the light it is probably more efficient, but this would be an option for controlling an analog track up to about 2 amps. So now we have a third option sitting over here, and that's a NCE Switch It Mark II. You see it up here, and down here is an NCE Dual Relay. So that's 2 sets of relay points. And this was also used in the Chuggington video to operate the MTH turnout and operate a status light. And you can see I've hooked a light up over here. And that's, at any rate, we can switch that using DCC just like we've done this other stuff. But this also has a set of push buttons hooked up to it. You can see the wires running from my fingers around into the back of the switch it. So you can see hopefully how that light back there is changing. So that's operating one set of the relay points to operate this light, which could be a status light, and the other set of the relay points could be turning on off a track. And again, we've got a capacity of around 2 amps, so we can run a train up to about 2 amps. And these can actually be controlled independently. One of these relays points can be in one position and one can be in the other position, because there's an independent control for each set of points with this switch it. Here's possibly a fifth option for these DCC controlled relays that you could use for controlling an analog train. Walthers makes these DCC switch machines. I have no experience with them. I just know they exist. The Center Model Railroaders group, which has a layout in the Discovery Center in State College, Pennsylvania, is using these, and they made me aware of them. But they'll operate actually on DCC or DC, and they say that they have like the Circuitron Smail. They have 2 sets of points. It's a double pull, double throw, and each each set of points has, they say, has a 5 amp capacity, so that's a little higher capacity than the Smail appears to be. And what we're looking at here is the horizontal mount machine, which is the 942-102, and they also make a vertical mount version, which is a 942-101. So that's another possibility. We can perform what we call a detector test here. If we run this program with nothing selected but the repeat button, the repeat switch closed, and I'll start it from over here. We had the public push button there, but there's a start button on the control panel. I'll start it here. You can see that thing is blinking continuously at about a half a second each. We have to put a time delay in there because if you try to run this thing infinite speed, it cuts itself off. But there's no trains being selected, so it's just running through all about 30 inputs from top to bottom, and then going back and doing it over. And there's a blink statement to send a dummy accessory command to a switch that doesn't exist, just to cause that to blink. So if we block the detector, I'm going to do that with a note card here. If I lay that note card in front of the detector such that it blocks it, you can see this blinking will change in a minute. There it goes. Now it blinks and then it pauses for about 3 seconds. We add a 3-second delay in if that detector is closed, and we can do that as a detector test. And if we take that note card away so it goes back to green, you can see in a minute it'll resume its previous blinking rate. So that's a way we can test our detectors. If we take a closer look at the detector assembly here, that's a Z-Stuff DZ1012 block signal detector. It shoots out an infrared beam at about a 45-degree angle, so when something blocks it, typically a train interrupts the beam, it'll change from green to red, and then it times out and goes back to green. It also has an adjustable time delay, but you don't really need that generally for DCC. It's useful for controlling analogs using the time delay. But over here, we've got a Z-Stuff DZ1008 relay connected to the block signal detector. So the bottom line is when a train crosses in front of that and changes it to red, it closes those relay contacts, and we have those wired back to the inputs of the mini panel. So that's how the mini panel, that is to say our programmable train controller, knows that the train is at this point. And what I like about the Z-Stuff detectors are essentially you can make them portable. You can see the thing's not attached to the track. We didn't have to cut a block in the track. We didn't have to drill any holes in the layout, wire anything up. This thing's just it's just laid down here. I brought the wires in over the side of the layout here and kind of tried to hide them with a barn. This layout actually belongs to a gentleman named Tom Martino, who was kind enough to loan it to me for this video, and I didn't want to drill holes and stuff in it. Now I typically I've got 2 of these DZ1012s. This is the other one. It's built almost the same. The one difference is you notice the DZ1012 is sitting up on top of the piece of wood, which is where I normally use it for N-scale use. So since N-scale trains are so tiny, I take it off the top of the piece of the wood and hot glue it on the side where you see it now, so it's down lower. And I also put a piece of tape on the bottom. There's no cover on the bottom of these DZ1012s, so if you accidentally lay it across powered rails, which I've already managed to do, you can burn these out, which I've done, and then you have to send them back to Z-Stuff to get them repaired. And they also make the DZ1011, which is the earlier detector, which will work for most everything from HO scale up, but for N scale, these work better. They're really oversized because they're an O-gauge detector, so if you want something that's more to scale, they do make an HO scale and a Z scale not a Z scale, N scale version of these, I believe. You could also be using a photoelectric eye or a reed switch or any of the various kinds of detectors that are on the market. Somebody recently told me that Tony's Train Exchange makes a device called the Sherlock, which is expressly made to operate with the mini panel for up to 8 optical detectors, also available from Tony's Train Exchange. And the Sherlock will condition the light to go into the detectors. That is to say, it'll adjust the lighting sensitivity for when you hook it up to the mini panel. You can hook an optical detector directly to the. You can hook an optical detector directly to the mini panel's inputs, but sometimes you have the problem of the light's too bright or the light's too dim to properly operate it. And the idea of the Sherlock is it adjusts for the lighting conditions. I think I mentioned this N scale layout. It was loaned to me by the guy who built it, a gentleman named Tom Martino, who built it and ran it several years in an event called Toy Train Expo here in Williamsport, Pennsylvania. And what I did, I printed out a picture from when he had it set up at the expo, and then I landscaped the layout as closely as I could, mimicking the way he had it done at the expo using this picture. I'll put a link down in the description to some pictures of this layout when he actually had it set up at the expo, and also I think there's a YouTube video he has showing it running. Let's take a quick look at the components here. You've seen most of these already. We've got our public push button over here. Here's our control panel with our programmable controller, NCE lighted to indicate which track is being operated. Atlas 205 slide switches we use to ground the various inputs of the mini panel, the controller, just to tell it what we want to do. Over here on the right, we've got an Atlas 56 push button switch normally used to control turnouts, but in the down position it gives us a start button that does the same thing as this button, but it gives us one on the control panel, and if we push it up and push it, it performs a reset function. You can see when I push the reset button, it blinks the indicator light on the controller. And then let's move the camera over first. Over here we got the rest of the stuff. We got the power control panel, which is part of the NCE power cab. We've got what we're calling our status light, which is actually a company no longer producing this stuff named South Bend, a G scale, but you can get, it's basically a red-green light. You can get these from other sources. And then we have an NCE lighted here that's driving this, I should say, controlling this status light. And then we have a NCE switch cat, which is controlling the AZATRAX relay here, the orange thing, and that's what's switching on and off the power in our stop block to control our analog train. And as I mentioned, say if we were running 4 or 5 analog trains, we just have 4 or 5 pairs of these things, one for each track, and our power cab would control the relays, but we use either big AC or DC transformers to actually power the track. Like say if you had LGB locomotives, you'd have a fairly hefty transformer putting power into the track, but the power cab still could switch the relay perfectly fine. And then over here, we have what we're calling our announcement decoder. This is built and programmed by a gentleman named Blake George, an engineer who lives out near Pittsburgh, Pennsylvania. But there's an NCE sound decoder you can see in the front, and then a speaker. And we increased the speaker size since the last video we used it in. It's larger now to get it louder. And this is storing 8 different announcements, F0, F1 through F8. We can play 8 different station departure announcements. We used 4 of them in this video. And then we're using the F0 function just like you would on a normal locomotive for headlights and taillights, except we made our headlight be the green color and the taillight be the red color. If I move the camera a little bit so we can maybe pick up the colors on this thing, and we can switch the direction. There it goes. It's going. I've got it in forward, and those lights went to green. And if I put it in the reverse, those lights go to red. Do that again. So there's forward, and there's reverse. So we can use our sound decoder to run a set of status lights, also using the F0 function. The other option would be to program a 9th departure announcement into F0. Then we'd have 9 available. And then over here, we just looked at it a minute ago, is our AC power pack putting power into the track. And incidentally, we're going into that track, so to speak, from the power pack to the track, and then we're coming down here to another track connector and pulling the power off, going to the relay, out of the relay, and into the stop block. And in this track connector, it's not hooked up, but we're just using it to indicate when there is and isn't power in the stop block. There's an impressively talented guy in Phillipsburg, New Jersey, named Tom Grassi. Tom has a 5-level, impressively detailed HO layout. Tom's been experimenting with using the mini panel to replace JMRI on some of his tracks due to it being less complex and not requiring a computer attached to the layout like JMRI does. Tom sent me this sketch for his upper level 5, which has 2 loops. And Tom has 2 trains on each loop, with 1 train running the short route and 1 train running the long route on each loop. Let's take a closer look. On the outer loop, he's got train 101 on the long section and train 39 on the shorter section. So using the mini panel, if he has train 39 parked, he can run train 101 around the long part of the loop several times. And when he wants to park it, he can start doing a time delay from the outer loop detector, and using time delay downstream of the detector, he can bring that someplace over here and park it. Then he can use the mini panel to align the turnouts to run the short loop. He can start 39, run that around several times, and use that same detector on the outer loop to do a time delay downstream of the detector to bring it in and park it. Then he has 2 trains on the inner loop, 41 and I believe that's 23, and he can run those 2 trains the same way. So Tom's experimenting with this right now to see how he wants to do it, but he has the option of choreographing a 4-train performance, same as we've done in this video with this N-scale layout, but he's using 4 trains but only on 2 loops, but loops with turnouts and alternate routes. And by the way, Tom has his own YouTube channel, which I've linked to in the description below, and he's got some videos showing how he's been experimenting with the mini panel, the programmable train controller. And Tom also made a video on the DCC Specialties Sherlock detector that we talked about earlier back in section 7, and you'll find that on his YouTube channel also. This brings us to the end of Part 1. In Part 2, we'll demonstrate programming the NCE Lights in accessory mode, loco mode, and we'll mention signal mode. Then we'll review the wiring diagram, parts list, flowchart, and commands used. Thanks for watching.